Hi, this is a probability question that we're going to solve using a tree diagram, but let's just read the question first. Jenny has a bag with 7 blue sweets and 3 red sweets in it. She picks a sweet at random from the bag, replaces it, and then picks again at random. Draw a tree diagram to represent this situation and use it to calculate the probabilities that she picks. A, 2 red sweets, B, no red sweets, C, at least 1 blue sweet, D, 1 sweet of each color. Well, let's start off by drawing our tree diagram. We'll look at the first pick first. There are 2 possibilities that she has, so we draw a sort of double branch like that. One represents her picking a blue sweet, the other one a red sweet. I'm using B and R to mean blue and red. Now, what about the probabilities of that? Well, because there are 10 in all and 7 of them are blue, probability of a blue is 7/10, and in the same reasoning, probability of red is 3/10. Now, what about the second pick? Well, she has replaced whatever she picked first time, so we've got exactly the same situation in the bag as we started with. So she picks a blue first, then she's still got the same probabilities of picking a blue or a red second time. And if she picks a red first, it's exactly the same again. So those are the probabilities for her tree diagram. We've just got 2 more columns to do. First of all, the outcome, and secondly, the probability calculations. Well, the outcome of this first branch is blue and then blue, so I've labeled it BB. And the probability is 7/10 times 7/10 because it's blue and blue. And if you remember, when you're ANDing 2 things, you multiply them together. That gives us 49/100. The next branch is first blue, then red, BR for short. 7/10 times 3/10, 2100. This branch here is first red, then blue, RB, 3/10 times 7/10, 2100, 21/100. And the fourth one is 2 reds, first red, second red, 3/10 times 3/10, 9/100. Now, it's always a good idea to do a check here because all of these 4 probabilities add up to 1 because they're the only 4 possibilities in the situation. And they do add up to 100/100, which is 1. So we've done our check. Now let's look back at the question. We need to work out the probability that she picks 2 red sweets. Well, we've actually done that one. It's this number here, 9/100. There we are. The answer to that first part. Second part, no red sweets. Well, the only thing which has no red sweets in it is the blue-blue combination. And we've already calculated that. That's 49/100. And so is that. Now we get a bit more complicated. We need to find at least 1 blue. So this has got a blue, this has got a blue, this has got a blue. There are 3 possibilities. And we get these by adding because it's this or this or this. And if you remember, or in probability means add them together. So when we add those 3 together, we'll get our answer. It's blue-red, red-blue, or blue-blue. Adding them together, we get that, which totals to 91/100. So that's our answer, but there is another slightly quicker way of doing it. Let's do that as well. Now, the only one which doesn't have a blue in it is this one. And seeing as we've got all our possibilities adding up to 1, if we take this possibility away from 1, then everything else must have a blue in it, at least 1 blue. So our working is going to be 1 minus the possibility of 2 reds, which is 1 minus 9/100, which is 91/100. Same answer, no surprise it's the same answer, but it's just a different way of getting to it. Now what about the last one? 1 sweet of each color. Well, that's just the 2 middle branches. First blue, then red, or first red, then blue. So it's this or this. So we add those 2 probabilities together. blue red plus red blue, 21 hundredths plus 21 hundredths, 42 hundredths, which we may choose to simplify to 21 50ths. Just finishing off, let's look at our tree diagram again. Remember that as you go along a branch, you're doing one thing and another thing, so you multiply the probabilities. Each branch has multiplied probabilities. But when you're doing answering questions at the end, you might have to add these because you're doing this or this, this or this, etc., etc. So remember, multiply along the branches, but add the results of those multiplications to get your answers.